Step into the world of groundbreaking research, where we're unveiling the hidden impacts of microplastics on phytoremediation, the natural process of detoxifying soil. A recent study led by Dr. Maud Kaifian investigated the effects of polyethylene microplastics on plant-based soil cleanup. These microplastics, less than 5 millimeters in size, are a growing concern due to their widespread presence and persistence in our environment. The study revealed that these microplastics absorb heavy metals like cadmium, lead, and zinc from the soil, potentially undermining the efficiency of phytoremediation. Hyperaccumulator plants, such as Solanum photinocarpum and Lantana camara, have a unique ability to absorb and accumulate high concentrations of these heavy metals. But when the soil was laced with varying concentrations of microplastics, the growth of these plants was significantly inhibited. The microplastics also reduced the accumulation of heavy metals in the plants, compromising their ability to clean up contaminated soil. What does this mean for the future of phytoremediation? It emphasizes the need to understand the complex interactions between microplastics, heavy metals, and plants in polluted environments. As we continue to unravel the mysteries of microplastics, it's clear that mitigating their impact will require innovative solutions and collaborative efforts from scientists, policymakers, and the public. Thanks for tuning in. Don't forget to subscribe for more scientific insights and discoveries. Together, we can make a difference in protecting our planet.